I want to go through Chapter 2 dealing with probability concepts. And from the underlying concept here, just want to spend some time with this video dealing with simple um, probability and joint probabilities. I'm sure most of you are very familiar with this, just due to the fact that this was in your stat class whenever you took the statistics class. Keep in mind in this particular document is a PDF document in your this week's lesson. But really what I want to spend some time on is, of course, there are two types of probabilities here. There's what we refer to as subjective probability, and that simply means that, in other words, we know the probability before the fact, i.e., we're going to take a coin and we want to determine the probability of coming up with a tail. Well, we know that, in other words, there's only two possible outcomes, head and a tail. Therefore, the probability of a tail on any given trial will always be 50%. We know that before the fact. So that's what we refer to as objective probability. Subjective probability here is a little bit, of course, we don't know what the probability is beforehand. It's only after the fact. And usually what I, in my seated class, I usually ask students, what's the probability that our economy may be in a recession next year? And of course, I'll get responses like 10%, 30%, 50%, 80%, whatever. And then I come back and I say, well, why did you say 10%? Or why did you say 60%? And students might understand that, well, it's probably from a prior econ class or it's from my experience. And that is what subjective probability is all about. It's based on one's experiences. So therefore, the probability of a recession, say within the next 12 months, I don't know what it is right now. But 12 months from now, I can tell you if you were right or if you were wrong. But the probability, the subjective probability is based on really one's experience in the area, we'll say in this case, of forecasting economic recessions or economic recoveries, whatever it may be. Mutually exclusive events, just kind of going through. Events are said, as I've stated here, events are said to be mutually exclusive if only one of the events can occur on any one particular trial. Mutually exclusive. Two events, A, B, cannot occur simultaneously. And then, of course, I give the addition rule for non-mutually exclusive events. If events are mutually exclusive, the probability is simply the probability of A plus the probability of B. If A and B can occur simultaneously, they're non-mutually exclusive, of course. And then to determine the probability of these types of events, probability of A or B will be the summation of the probability of A plus the probability of B. And then we have to subtract out the joint probability that A and B may occur simultaneously. What I have here under 5 is a contingency table. And a contingency table here, in my column gender, males, females, of course. And then I have those particular under 30, 30 to 45, over 45, and then totals. My sample space, my total sample space is 200. And we can look at simple probabilities from the perspective, okay, what's the probability of a male? Well, male here, right, I can just read across, I'll have 120 out of my total sample space, total number of 200, and you can see, yeah, 60%. Straightforward, easy. Likewise, probability of a female. How many females do I have in this particular sample space? I have 80. 80 out of 200, or 40%. And then I can also say probability of over 45, another simple probability. I'm looking at my table, over 45. I'm not specifying male or female. I'm just saying, okay, for gender, what's the probability of coming up with an individual, male or female, that is over 45. And I have a total of 50. 50, of course, divided by my sample space, or my total number of 200, gives me 25%. Here under D, probability of female and over 45, of course, that's joint probability. And so what I'm saying here, okay, probability of male, so, probability of female and over 45. So probability of female and over 45, my inflection point here, I have 10 individuals that meet that particular criterion, female and over 45. And as you can see, 10 over 200, 5%. In this particular case, another joint probability. This would be probability of male or under 30. So, okay, I have a probability of males that we came up with before, 120 divided by 200, or under 30, right? I have under 30, I have 100 divided by 200. Now, as you can see, remember I was talking about mutually exclusive events and non-mutually exclusive events. Mutually exclusive events, outcome A, I should say event A or event B cannot occur simultaneously. Well, if I take the probability of male and add it to the probability of under 30, you can see what? Well, my probability is greater than 1 or greater than 100%. That can't happen. And of course, that's the dead giveaway that these events, A, B, male, under 30, are not mutually exclusive. They are not mutually exclusive events. So we have to take into account that segment, that portion. If you recall once again from your stat days, we're looking at a Venn diagram. In other words, that particular area of those two circles, event A, event B, that in other words can occur simultaneously. So that's what we have to take out. So in other words, it would be, yes, probability of male plus probability of being under 30. And now what we have to do is subtract off that area of the Venn diagram where they may both occur simultaneously. And that would be male and under 30, 60 in relation to 200, or 80%. And then you might want to go through and, of course, explain why F. Are these events mutually exclusive? Of course not. And then we have some conditional statements. I just want to spend a moment or two on this. Conditional probability, probability of A given B. Now, what this is telling us is that, in other words, it's conditional upon something. That is, I know something about one of the events. In this case, whenever you see probability of A given B, / given B, that is telling you something. I know something about B. B, I know. Now what I'm saying is, what's the probability of A given B? Like in this case, probability of male given under 30. I know I have reduced my sample space from 200 to 100 because I'm isolating on an event that is already, I know something about. That's under 30. So here, probability of male given under 30, I know event B. So it'd be 60 in relation to 100, or 60%. So just might want to spend some time on conditional probability. As I indicated, I just wanted to go through simple probability, joint probability, and of course conditional probability. As I pointed out, probability of A given I know something in regard, in this case, to event B. So I'm not going to spend a lot of time on probabilities as such. This is just probably an overview, a rehash of what you've already had. Hopefully this little video will be beneficial. Thank you.